Okay, so the next frontier, according to you, is dealing with the cars, so autonomous cars in general. But now you talk about the hardest part for a humanoid robot would be manipulation and not grasping. So also for a humanoid robot, it probably the fact that uh, one humanoid robot is not responsible for one specific kind of job. For example, picking an object maybe, but a variety of different kinds of tasks, and that adds to the challenge because the artificial intelligence technology that we have is currently focused on one specific kind of problem, so the narrow AI thing. And for humanoid robots to operate in homes, they need to be more general purpose. Can you also tell a bit of difference between general purpose robotics and the approach that's there behind it, and the narrow AI way of dealing with robotics?
Yeah. Well, the general AI concept is to build machines so that can apply different type of models to different tasks, right? And to some sort of limitation, we can build robots that can be okay. For example, in industry, these robots were pre-programmable. So that means that you sell the same type of robot, but it
Yeah,
can do many different operations. But typically in the industry, what you have is a line of robots, the same type of robots, but you have a line of them. Each of them does a particular task. Okay, so although you are selling one robot that ideally could do several operations, um, when in practice, what you want to have is a robot that is set up in a particular place to do a particular task or one or two tasks,
yeah,
not many. Okay? Um, well, that also it's because efficiency and stuff like that. But if you consider, for example, a robot manipulator that can do several operations like painting or screwing stuff and whatever, well, doing that with a human hand, right, is going to be very difficult. So what you prefer is to have a specialized tool attached to the robot arm that does
yeah,
that particular operation. So it's better to have two robot arms, one with the spray to paint the car, for example, and the other with the screwdriver that can screw things
yeah,
on the car. So instead of just swapping around the tools. And if you think about a robot that wants, you want a robot to work in your house and do all the tasks that a maid would do, well, doing it with two humans' hands is going to be very difficult. So what you want is actually specialized robots that are able to do some particular task. And right now we are at the point where there are robots around the house, like the dishwasher,
yeah,
the washing machine, the coffee makers. They can be seen as robots. They do a particular task, right? And you can have uh, all these robots connected together, working together, and you can control the robots. You can control the thermostats of your house from your cell phone, right? So you can pre-program some particular timing for doing the action. So you activate in you can schedule the activation of these tasks, right? Um, but because they are specialized robots, they know how to do that particular job, and they are designed not as humans, but they're designed as the with the best design to accomplish that particular job. So
yeah,
the washing machine is just a cube where you fill clothes inside. It's not a humanoid robot who goes to the river and starts, putting your clothes into the water, right? So
yeah,
that's how we design specific robot for particular actions. Obviously, from the research point of view, it's very interesting to be able to build a humanoid robot that is more capable of doing things, right? Our goal for the research is not to build a robot that looks like human, can fool humans and act as human, right? Is um, the the human design is taken for some particular purposes because it's easier also for us to encode to represent particular task if we have some particular design like the one we are comfortable with, like for
Yeah.
example underwater robots that needs to pick objects from the seafloor or do some operation of restoration under a boat, for example, or wherever. Well, if I have to design a robot like that, I will design it with the two arms, right? Because I know that if I needed to do some assembly task, perhaps one hand is not enough. You need support with the second, and
Yeah.
maybe having three could be also useful for a particular situation. But I know that with two hands, I can actually do most of the stuff I want to do because as human, I'm interacting with my world with two arms. So that is actually the reason why sometimes we tend to design robots as humans, not because they need to, but because we know, why that design works because we're using it all the time, right?
Yeah. Yeah.
But yes, to go back to your questions, generally, I don't want to say as lost interest, but is nowadays more a theoretical point of view, is a theoretical investigation if it's possible to actually generate different behavior, how to combine behaviors. But most of the robotics they are actually working on real problems. They
Yeah.
tend to specialize the robot. They perhaps use the same robot and try to accomplish different tasks, but it's difficult to see a robot that, although you have developed the same task on the same robot, it's difficult to see a robot that then combines all these tasks and executes all of them. Okay, so you have
Yeah.
one specific set of algorithms that enable the robot to do a particular thing, and then you have another set of algorithms that enable the robot to do something else. Okay, and
Okay.
in that way, you can evaluate design, you can evaluate algorithm, you can evaluate the if the ability of the robot has grown and got went behind the state of the art of yesterday, and but typically you need to create models, you need data to create these models, you need a lot of information to keep around, and if you start adding multiple tasks on the same robot, then you ended
Yeah.
up that you need big spaces for your data, big time for your processing, and that's something we can't really do right now. There are a lot of research on long-term, long-life robots. Like, for example, if you think a robot that has to work in a hospital as a service robot, uh, well, ideally that robot should work constantly, 24/7, right? So he needs to be able to, you know, learn new things, specialize to the particular hospital he's working on, if they're, memorize where the reception is, where the rooms are, where the service rooms are. And these things, you don't want to lose it over time, right? So you need to, by a certain point, you will get so much data, you need to figure out what data I can lose without actually losing knowledge.
Yeah.
So that's another problem. Trying to compress data, combine data, lose the data that will not make the difference. Okay, so that's where we are, and there are a lot of projects, especially one that comes to mind is Nick Oves at the University of Oxford. Is working on this area. They're making a great progress, but still, we don't have, robots that can work for years without never being, required any help from the operator.
Yeah, that's quite interesting. So I have two questions for you based on the things that you shared. So yeah, I understand this thing that only specialized robots are possible. A general purpose robot is not possible, and it's not even the focus of research. So, but is it possible that, for example, consider a robot manipulator arm, and can we so essentially the fact that it can perform one particular specific activity, maybe it's picking an object and placing it somewhere, it's dependent on the program that we wrote, right? And maybe there's another activity that it can do, I don't know, maybe yeah, any other activity that it does. So but we can have one particular robot manipulator arm, and then we can switch different modes to make it operate between different specialized robots. For example, maybe one particular robot that is in an industry, in a power plant, maybe picking objects, can the same robot can be switched to a different mode, or maybe multiple modes, and in a way that is that particular robot is now capable of doing a lot of different kinds of tasks, but it is at one particular point it's just a specialized robot, right? uh, yeah, so I'll let you talk about this thing, but then I'll also state another question that I have. So you called a dishwasher and a washing machine as a robot as well. So how do you define a robot? So I have these two questions basically.
Okay. So yeah, yeah, definitely. We have shown that the same setup, the same robots. If you take, for example, Baxter. Baxter is a humanoid robot that is a unique design. Um, Many university and research center and also companies have bought this robot and specialize the robot to do a particular set of tasks. Um, so the same design, the same architecture has been used um, uh, to accomplish different tasks, and that is possible. But you have some limitation on the number of tasks and the complexity of the task that you
Yeah.
can execute the same robot because limitation in the space, the data you need to acquire and stuff like that. So building a android like the centenary man, it's still far away
Yeah.
on the and if I can may add also my opinion on this, we might actually reach the point where we get humanoid robot that can work around us, and that is actually, I hope we will reach that point. However, all these debate around, if it's correct to have robots that are stealing jobs or stuff like that I don't think is actually matter this debate because if you look at Centenary Man, which is one of my favorite movie, though if you remember, the story has is like the it was like our world in the 90s, right? But with this big change that there are androids that can work autonomously and they are very close to a general AI kind of way.
Hmm.
So there is a scene where there is the owner of the robot that is reading the newspaper outside his balcony, right? And there is the robot next to him that is serving. Okay, on newspaper. To understand, in the 90s, obviously we were getting our news on the newspaper, but 30 years later. nobody uses newspaper anymore, right? So
Yeah.
it's unbelievable that that particular technology will actually be ready if, you know, in that particular world, the world would have developed accordingly. So right now we are, having cell phone to check for news or a tablet, right? I would imagine that if we reach the point of having autonomous Android in our house, we might reach the news from, I don't know, a chip in our brain or something like that. Of course, some goggles that can show us the news or something like that, like a minority report kind of technology, right? If that technology is not ready, I don't see why that should happen. And obviously, if magically we ended up having an Android on the 90s, then obviously that will start stealing jobs to people that were specializing in that particular job and didn't have the time to actually move to a different job. But I would assume that when the Androids will be ready, people careers have already moved away from the jobs that they were doing 30 years ago, they are doing now, and that is not going to be a problem. Like the car was not a problem when we stopped using horses because
Yeah.
gradually got inside our culture, right? And people have over generation have changed the job, and they found actually better jobs that are easier, they are less demanding, and also the lifespan has grown for human beings because a lot of hard work were actually not necessary anymore and they were substituted by other type of jobs. Okay, so that debate just added, I believe, most of the times when we debate about this kind of stuff, people that are not in research on robotics, they tend not to analyze this point of view, and in my opinion, is actually quite important. Uh, to move to the second questions, that was what was the second question? Sorry.
So it's one question was the specialized robot thing, and the other question was what is a robot, because you called the dishwasher and yeah.
Yes. Well, I said robot. I didn't say intelligent robots, right? So a robot is actually a machine that does some operations.
Okay.
Okay, you uh, programmable robots are robots that can have multiple functionalities with the same design. You just need to change the code, right? So a dishwashing machine is is programmable, for example, right? It has different type of washing setup. You can change it, and you can add new ones if you want, and um, and intelligent robots is something. Well, we needed to describe what intelligence is, right? Intelligence, there have been tons of definition around the web and on books. If you look at the textbook for AI and machine learning, every book gives you a different definition of intelligence.
Mm.
Uh, what I like to consider intelligence is coming from Professor Winston from the MIT, and he said that you know intelligence is having a model, but a model that targets thinking. So it's not just a model to solve a particular problems, but it's trying to understand what is the thinking process in order to solve that problem. Okay,
Yeah.
so the reasoning, inference, having raw data, extrapolating and patterns, and this kind of stuff. Okay, so the models target a reasoning path to achieve a particular goal. Okay, unfortunately, that's not quite enough because models are based on representation. Okay, because for example, a very classic example in AI is the farmer fox goose grain. Okay, you have a river, you have a farmer needs to move all the items
Yeah.
across the river, but on the boat it can be only him and one of his items. And you have to decide which one you have to leave on one side, which one you take on the boat, and you move it, right? And you know that the fox wants to eat the goose wants to eat the grain. So you have this particular set of constraints you have to figure out in order to find the solution. So in order to generate a model from these problems that I described you by words, you need to have a representation of this problem, right? And one possible representation is I had a visual representation. You draw, you know, the river, you draw the elements on one
Yeah.
side, and then you draw another the same scenario but with an action. So you show that now the farmer and the goose are moving across the river and whatever, right? And you from one state, right? Because this representation represents one state, a particular situation, a time t. You can draw connections to possible evolution of the system, right? So visually, you can represent what are my options from this state, right? And then you can draw what are the options from another state,
Yeah.
right?
Yeah.
So the representation becomes a graph or a tree, depends on what kind of problems you have. And the nice thing is that in some particular problems, like this one is very simple, the number of combination not that high, you can actually draw it in one blackboard, okay? And you visually can see that there are some states that do not satisfy the constraints of the problem. Um, So what I was saying is you have this representation. This case can be visually representation of really drawing the states and how the states evolved, and you can identify states that are not legal in our problem. So you expose the constraints of your um, of your problems, and you can find an algorithm that will satisfy the constraints for the
Yeah.
representation we have chosen to support the model. And and the model solves the problems that is how you reach the solution to this problem. So what is the thinking process you need to employ to actually reach the solution of this task or similar problems, right? So in from a very again very practical terms, this definition of intelligence is
Yeah.
actually more suitable for me because it goes back to writing algorithms, right, of a mathematical formulation of some kind that tries to replicate the thinking process of my brain when I try to solve a problem like, you know, how to move all my items from one side of the river to the other without losing any item, right?
Yeah.
So that is what we that's what I consider intelligent. And if a robot has this ability, his ability to, you know, um, execute an algorithm or learning some, some models that are able to define this thinking process, then that robot is intelligent. So a cart that can navigate from point A to point B without hitting anybody or any other carts, then is a intelligent behavior because it needs to think about staying in the lane, It needs to think about dynamic objects that are moving around and having some responses, some actions that enable the car to be safe and reach its target. Okay, so that's how I would define a robot that is intelligence by
Yeah.
a robot, which is just a machine that executes actions.
Okay. So, so essentially, the robot that you're talking about, by the term robot, you essentially mean a machine. So, what exactly would be the difference between a machine and a robot from this particular, definition that you talk about? So, or a machine could also be, a robot could be, a subset of a machine in a way, in that sense, and then an intelligent robot is then a subset of robot.
Yeah, yes. I would say like a machine is very general terms, so, right? We can call the dishwasher machine, right? But
Yeah.
in if we wanted to define a robot, the robot is a machine that is able to execute some particular actions by himself. Right, so is robot is a very old name, comes from the literature,
Yeah.
uh, and he defined this idea of an autonomo that can execute actions, right? While a simple machine would be, I don't know, a mechanical machine like, I don't know, a spray machine, right? You press the trigger
Okay.
and
Okay.
that's a tool machine, right? Which has nothing to do with the robot.
Okay. Okay. That's interesting. So now let's move a bit more deeper into the interesting projects that you have done. So, but before that, uh, let me ask you this question: why don't we still have robotic grasping arms at home already? Yesterday we had a conversation where you were talking about uncertainty and how it uh, impacts the design of a robot, for instance.
Yes, I believe I already answered this question in some parts.
Yeah,
The key is that manipulation requires to generate contacts with the world, and there is uncertainty in the sense that most of these interactions cannot be predicted because there are a lot of variables we cannot measure, right?
yeah,
So lack of measuring variables, lack in the model of, some particular value you should assign to that particular variable. So your model does not know what is going to be the outcome because you don't know um, what are the coefficient of frictions or this kind of stuff. Um, if you have a pile of objects, for example, you take the one from the top, uh, predicting if they are going to fall and how, it's very tough problem. Not even our brain can actually solve this problem, right? We can understand when something might fall, right?
yeah,
But
yeah,
predicting exactly how that is going to happen is going to be very difficult, right? So we have limitation ourselves. But I think the biggest limitation now is a technical, is on the I told you there is these three-dimensional topics for researching in
yeah.
robotics. Uh, the perception part is not just only a camera watching an object, understanding that is a glass and the other is a guitar or whatever.
Hmm.
Um, it's also sensing, be able to touch something and have the right sensitivity to manipulate an object. Okay, like for example, if you have a pile of plates and you want to, you wanted to lift the first plate, you need to have also sensing to understand where the object is, the gap between the two dishes. You need to have um, soft ends that enable you to apply the right frictions to lift
Hmm.
the first plate enough to place your fingers below. So there is a lot of movements which are extremely complicated to model on the physical part, because involves forces, sliding, frictions, this kind of stuff. And so now we don't have actually the tool to do that. Even if we could model in simulation on a particular defining a bunch of these variables, and we could have in simulation something like that. In practice, we don't have a robot to do that. So there are limitations.
Okay.
And for that reasons, these three axes are moving at a different speed rate, because technology does not advance in all these directions at the same time. And
Okay.
some can be advanced by using simulations and recreating worlds where we can test our hypotheses. In some other cases, if you don't have the technology, the hardware technology, you don't move forward. Okay, so indeed, if you go to to a robotic conference, typically there are several tracks. And tracks can be on computer vision, on sensing, on developing hardware for computer vision, sensing, and processing, or you know parallel processing for make a robot or intelligence machine um, faster. There is decision making. There is how you can learn from data, how you can extrapolate a particular hidden pattern from raw data, and this kind of stuff. So it's really 360 degrees. It touches many different aspects of the problems. But unfortunately, not all of these tracks go at the same rate. So sometimes these create limitations for the real application. Well, sometimes, most of the time.
Okay. Yeah, that's quite interesting. So now let's move specifically to the projects. Let's first start with the dishwashing robotic project that you had. Can you tell us more about that?
Yes. Well, the idea in that case was, that you place a robot in front of a desk where you have a dishwasher rack and you have a pile of household items that can fit in
Mm-hmm.
the so dishes, glasses, cutlery, and this kind of stuff. The problem was obviously again you had the perception part where you try to see the scene, understand what is an object, what is not, what kind of objects, understand what object could be graspable, because if they are piled together, some objects cannot be grasped. First, you need to grasp some other object and so on. There were also we had these bimanual robots that was able to scan the environment,
Okay.
create a 2D model of these objects, and apply grasp to different objects. And we were selecting the object to grasp, following this constraint, grasp it, passing to another hand, and again the
Okay.
grasp was computed on the fly. We have this model for adapting grasp for different hands and different objects, and then he was he had to know where to place it in the dishwasher. So again, we had the model to tell things that looks like dishes that are flat and round, go in this part of the rack. Things that looks like glasses or goes in the flat part of the rack, and so on and so forth. So we have this model. The nice thing was that the model to place the things inside the rack was the inverse model, if we can call it like that, of the grasping. In the grasp, if I can take an object like this glass, right, I learn on this grass that I can place my fingers like this. So I generate a
Yes.
bunch of contacts with the surface. space, right? So I extrapolate some feature to describe the position I want for this object. Now, if I get this glass, which is very different from the other glass,
Yeah.
but the local contacts kind of are the same, right? So I can transfer this grasp, and I can learn the grasp on one glass, and then I can see another glass and or similar shape and apply the same grasp. When I place it on the rack, I can do the opposite. I can uh, associate the contact between not the hand and the object, but between the rack and the object. So the rack works like the hand.